Hello, my name is Graham Sexton, and I'm going to be taking you through this slide set today, which is looking at the hardware setup that you're going to use for your experimental work, where you're trying to take measurements of throughput through your wireless link. So the hardware setup is shown on this particular slide, and we have a number of PC devices shown here. You need essentially two devices, although three is much better. We need one PC to host the Jpath server and another to host the Jpath client, and ideally a third PC to host either Channelizer or AirPCAP and Wireshark, or both of them potentially. And of course, the other piece of equipment which is absolutely essential to this experiment is the actual access point itself. So I'll just mark up the access point there. The access point can be almost any access point, as long as you can set it in the appropriate mode, either 802.11a, b, or G, depending on what you've chosen to do. So the idea is to set up one wireless link between one of the PCs, and I'm going to, in this experimental arrangement, I'm going to set it up between the Jpath client and the access point so that we can transmit wirelessly. I'm just drawing some wireless, there we are, symbols there to show the signal going from the Jpath client to the access point. Now, the connection between the access point and the Jpath server under normal circumstances would not be a wireless link, but we would have a wired link, and we would connect from the access point to the Jpath server using an Ethernet cable, and so that would be plugged into one of the Ethernet ports on the server side and one of the Ethernet ports available on the access point itself. And in this particular arrangement, the direction of travel of the data as a default will be between the Jpath client and the Jpath server. You can switch it around in one of the Jpath client settings, but that's the default direction of travel. Now, in order to make all of this work, we do have to ensure that we've got the access point and the IP server PC and the IP client PC set up appropriately. So there are a few little things that we need to do, and there's a slide that we'll jump onto after we finish this slide, which will help you if you don't understand. But you have to ensure that the IP server, IP client, and access point all have IP addresses on the same network address. And under normal circumstances, my recommendation is that you disconnect the PCs that if you're using lab PCs, disconnect them from the room network and just have them connected physically only to the access point. That, of course, will cause a few issues, probably because the PCs have their network addresses normally set by a DHCP server in the lab, so you'll have to do that manually, but we'll discuss that more in the next slide. Now, from an access point of view, there are a few things that you'll need to configure. So you'll need to ensure that you can get to the access point administratively, and there will be a default setting for your particular access point, and it's partially incumbent on yourself to find out what that default setting is. It might actually be written on the access point, but if it's not, then what I would suggest is you Google the access point and find out what the default setting is. You may need to reset the access point to force it to take on the default settings, but by that time, eventually, you will have discovered what that IP address is, and you should be able to then connect one of your PCs to the access point, and then point your browser at the IP address of the access point, and then log into the access point and change a few settings. So you will have to set your access point to the appropriate channel type. So your channel type is going to be either A, B, or G. Now, it's quite possible if you've got a very recent access point that these settings might be known as legacy settings. So you might have to look for a legacy type setting rather than A, B, or G. Obviously, the B and G operate at 2.4 gigahertz and the A operates at 5 gigahertz. You'll just have to select that appropriately depending on what you've chosen to do from your experiment. Initially, I recommend that you carry the experiment out without security switched on, get everything working, get a set of results, and then switch security on, whether you use WEP or WPA. I think that's your decision. That's just about it really in terms of the access point configuration. One other thing that you might need to double check, sometimes on some access points it's possible to set the access point at a sub-maximum rate. So just have a quick look around on your access point to make sure that the access point is actually operating at the maximum data rate for A, B, or G. So assuming we've got all the IP addresses set up now, we need to think about making sure that we have the best channel for the experiment. And again, this is something that you'd have to set up on the access point itself. Some access points have got dynamic frequency selection or dynamic channel selection. That means the access point assesses the best channel to work on itself, but that's not necessarily what you want to be able to do. So what my recommendation is you try and use Channelizer, which is a form of spectrum analyzer which will allow you to look at the spectrum at either 2.4 gigahertz or 5 gigahertz and find out which channel is the quietest channel for you to use, and then select that explicitly in your access point. And of course, once you've set an SSID for your access point, make sure you know what that is. Then your iPerf client will be able to connect to that particular access point. So once you've kind of chosen the best channel using Channelizer, then you start to need to run iPerf, and my recommendation is you have a look at my video on how to use iPerf, but we've got a slide in a couple of slides time which shows you how to run iPerf. So obviously you need to run iPerf at the server end and iPerf at the client end. I've got some extra guidance, as I say, later on to do that. Now my recommendation is once you've established that iPerf is running, then you use Wireshark to take a quick look at the packets. It's really valuable to do that because although you may think everything's working really nicely, you may well find that you've got a little error in something that you've typed. But if you look at the packets using Wireshark, then you can confirm whether the packets are in fact what you expect to see or perhaps not, and then go back and tweak something if something's wrong. When you're running your experiments, it's important to realize that you need to run each experiment with each payload more than once, possibly up to 5 times. It depends on how variable the throughput is for each time you run the experiment. But essentially you need to collect a series of average results one way or another. And there are a number of ways of doing that averaging, but it's useful just to run the experiment several times and take an average over that period. And of course, you know, the aim of the experiment is to actually vary the payload size. So you need to think about varying the payload size probably from around about 100 bytes all the way to maybe 2000 bytes. And that means you're probably going to do 100 bytes, 200 bytes, 300 bytes, 400 bytes. So there's quite a lot of results to collect, and it does take a few moments. But that's about it. That's your experiment. Now what I'm going to do is to take a quick look at setting up your IP addresses, just for those of you who are not so familiar with setting up IP addresses. So here's a quick resume on IP addresses, and so my recommendation is that you use static IP addresses for this particular experiment, and I've given some example IP addresses that you can use. You don't need to use these addresses, but you know, they will work. So in this particular case, the important thing from an IP address point of view is to ensure that the network portion of the address is common on all three devices, and the host portion of the address is different. Now the subnet mask, which is this number on the right hand side, I'm just putting a red line over, is the mask that defines the network portion, and within the mask, the mask is a 32-bit number, and every bit in the mask that is a 1, the corresponding bit in the IP address is a network address. So the first 3 octets in this mask are 255, 255, 255, and that implies that the first most significant 24 bits of this particular mask are all ones, which corresponds to these 3 octets over here being network addresses. The last octet here in the subnet mask is a 0, implying that the last octet in the IP address is a host address. So if we take a look at these examples, we've got 192.168.1 for all 3 addresses, and we've got 1, 2, and 3 for the host addresses. So that satisfies the requirement that the network portion is the same, but the host portion is different. So that's what you might use if you use static IP addresses. And if you do use static IP addresses, you will need to configure each of your PCs. You'll need to go into the network settings and go down to the particular device, the Ethernet device, and change the IP version 4 properties to change the network settings, so you can input the appropriate IP address and subnet mask into those network settings, and do something very similar in your access point. Now you don't have to use static addresses. You can use dynamic IP addresses, and as a default your lab PC is probably using dynamic IP addresses. I can recommend that you don't use the lab DHCP server if you do want to use dynamic IP addresses, basically because you then have a little problem of assigning an IP address for your access point, and it's a little tricky to ensure that the IP address isn't already taken by some other device within the lab. Of course you can do it, it's just a little bit more tricky. Also, you can use, or often use, the access point as a DHCP server itself. Most access points will have DHCP server options, and so you could enable the DHCP server on your access point and assign addresses to the PCs. Now if you do that, you must ensure, absolutely must ensure, that the lab PCs are not connected to the lab network. Otherwise you can cause problems in the rest of the laboratory by in effect running 2 DHCP servers in the lab. So final slide, just going to have a very brief look at running up iPerf, potentially Jpath. Remember the difference between iPerf and Jpath is simple. Jpath has a graphical user front end. It has iPerf behind it, so the engine generating the packets is exactly the same, but it has a prettier front end. And if you want to use Jpath, that's absolutely fine. I don't actually have any guidance on using Jpath in this particular video, but it's very straightforward to use, and the settings that you have to set are just the same, but you would do it in a graphical way. So for Jpath 3 in this particular example, at one end you have to run the Jpath up as a server, and the sort of command to do that, super simple, Jpath 3 space -s. Now if you're going to use Jpath, then there's a little ticky box in there, and you need to specify it's running as a server, and that's all you need to do at the server end. So now looking at the client end, and as a default the client sends its data to the server. The client end command is a little bit more tricky. So the few things that we need to do, and you need to do this pretty much for the Jpath or the Jpath. So we need to specify the server address, and the server address in this example is 192.168.1.1. It may not be the same for you, depends on how you specified it, but you need to tell the client where the server is. And you also need, for Jpath 3, to tell the client to generate UDP packets, and you do this with the -u option. Now when you're running Jpath, it's probably an oldish version of Jpath, and you need to tell Jpath that you want to receive UDP packets as well. With Jpath 3 itself, you don't need to explicitly tell it that you're going to receive UDP packets. So the next thing you need to do, you need to say something about the payload size or packet size, and the Jpath 3 method is you specify -l, then the number of bytes in your payload. That's done slightly differently in Jpath, but you specify the packet size in one of the boxes. You also need to say something about bandwidth. That's the last parameter here. And as a default for UDP, Jpath generates only about 1 megabit per second. And we need to generate far more than 1 megabit per second to saturate our wireless link. It really depends on your wireless link, on how many bits per second you need to be able to saturate it, but certainly for an 11B link, we will easily saturate it with around about 10 megabits per second. In this particular example, I'm using the -B20M, which will generate 20 megabits per second, which will more than saturate the wireless link of an 11B. But if you're running 11A or 11G, you might want to increase this parameter, this 20M parameter, to maybe 30M. And that will ensure that the link is saturated. When you run Jpath, you'll see when it's running, you'll see some data about the rate of transmission, and you'll see some examples in my YouTube video, which the link is just there for more details, and that's where you'll get your raw data from to actually generate your final results. And that's about all there is to it. Of course, there will be things that won't work exactly the way you want, and it's very hard for me to cover every possible eventuality in a short video like this, but at least hopefully this will get you off the ground and running in the right direction. Thanks very much for watching.